Hi everyone, my name is Kingsley Doko and I want to welcome you back to uh, the video on Juniper SRX clustering, right? We've been on this topic for a very long time now. We've looked at different implementation. The devices are in a cluster. We've configured the control link, the fabric link, the right interfaces, both for the LAN and the WAN link. We've tested failover, manual failover. We looked at the different transition stages. We've also done automatic failover with monitoring of interfaces, So we've really covered a lot. So if you've not watched this video, you can go back to the playlist. You'll be able to get everything there. This is going to be like maybe the last part of what we're going to be discussing about, and it has something to do with IP monitoring. Now, why do you want to monitor IP? So it's almost like IP SLA tracking. Okay, if you remember in Cisco, there's always that concept of IP SLA, right? Tracking. I think most Cisco devices support this, where you have some IPs on the internet or your gateway that you continuously ping. So long the IP is reachable, then you are going to keep the route in the routing table, or so long the IP is reachable, you want to take that route out from the routing table. So it's something like that we want to also implement here in this use case. This is Juniper though. Now the idea is this. In the previous video, we did monitoring of these interfaces, right? We said if there's a failure, let's say here, then it should initiate a failover for the redundancy group 1. Okay. Now, why this might be okay for the LAN side, this is the LAN. For the WAN network, you could still run into some issues, okay? Because you can have a situation whereby this link is fine, there's nothing wrong with this link, okay? But for some reason, this device is unable to reach the internet, okay? So let's say you have 8.8.8.8 here, okay? So you could have a situation whereby, yes, this is our primary, right? So this primary cannot ping 8.8.8, okay? The internet is broken, but it's not a problem from our end, okay? It's not a problem from this private network, okay? For this private network, okay? It's a problem. It could be connectivity problem, right? Yeah. I understand like this topology might not clearly explain properly what we are trying to say, but let's look at it this way. So let's say this connection actually goes straight to let's say this is your service provider, right? Yeah. So they could have two redundant devices here, where one connection lands on this could be R1 and this could be R2, and the R2 comes here, okay? Yeah. So you have direct connection to these devices. That could be like if in the case of Arista, they could be they could be in MC-lag, right? MC-lag, right? Where they are doing active forwarding, okay? So if that is the case, where you have maybe two last mile to these connections, then you want to be able to track your IP, the virtual IP at this point here, okay? So let's say here there's a virtual IP, okay, that they are both pinging. So it's still the same subnet, or within this, it's still the same broadcast, but they have their individual last mile. So you want to be able to track this link and say, so long I'm able to reach this IP, right, from the primary as well, so long I'm able to reach this virtual IP, which is the gateway on the service provider end, then I want to the primary should always stay as primary. So at any point where the primary is not able to reach this IP, this virtual IP that we have here, let's say in the case of our subnet, let's say it's 192.168.1.1, okay? We'll say the moment you are not able to reach this IP, then go ahead and fail over to the secondary. That is, if secondary can reach the IP, but the primary cannot reach the IP, okay? So it means there's something definitely means this last mile is broken, right? From the service provider standpoint, okay? So it means this link is broken, so you want to go ahead and fail over to the secondary, So that's the whole idea. I think it's much more accurate, right? So in addition to your, the interface you're monitoring, which is within your domain, you want to also be able to track IPs on the internet. So it is not just the gateway. You can have so many IPs that you want to monitor. I believe in some Juniper devices, you can monitor up to 64 IPs, right? I don't know how many it support any virtual devices, but some devices support up to 64 IPs. Now, what is really happening here is for you to do this configuration, you need to set certain parameters. Number one is you're going to have something we call the global weight. Okay, right? You're going to have something we call the global threshold. Okay, then you're going to have something we call retry count. Okay, and of course the retry interval. Okay, so what happened is for this connections, right, for this IP monitoring, we're going to set a global weight. We can say, oh, the value is 255. Okay, and then we'll say per IP that we are monitoring. Let's say we're also monitoring 8.8.8.8, 4.2.2.2.2, right? We're going to set each one to have, they call it cumulative threshold, right? So here we can say the threshold is let's say 200. Okay, so each IP will have a threshold value of 50, 50, 50, right? I think there's still 4.2.2.3, 50. Okay, so what that means is if the gateway is not reachable, this is not reachable, it means you're already minusing 100 from here, right? So global threshold value becomes 100. So in this case, it will still not fail, right? So this global threshold, you need to hit the global threshold to trigger the global weight. Now, once the global weight is triggered, it's going to take this value and minus it from your redundancy group. Remember the value for the weight for redundancy group is what? 255. Okay, so we're still coming back to the redundancy group value. Okay, so that's really the way the implementation is. Here is, okay, how many timeouts do you want to have? Okay, I'm going to say if I send 5 pings, if I send 1, 2, 3, 4, 5 and I don't get a response, it means that IP is not reachable. So I'm going to take my 50, which is the weight assigned to that tracking of that IP, and then minus it from the threshold. Okay, then you can say, oh, my interval is every 1 second. So it means in 5 seconds you should be able to detect an IP is not reachable. Okay, that's the whole idea of IP monitoring, where you're able to actually, you are not just looking at the interface status, as in this case, rather you're actually checking connectivity, you're actually checking for reachability of the destination, right? Then of course, the most accurate one to do is to actually monitor the gateway, which could be on your end or on the service provider end, like in our case here. Okay, so it's just another way of assuring that your clustering is working as efficient as possible. So for us to enable the IP monitoring, these are the commands that we need at the basic level. Okay, so we also point these IPs that we want to monitor. In my case, I think I'm just going to, so here is what we are going to implement. So in my case, let me bring the if device out. Yeah, so this is if, let me drag it here. Need to do a refresh. So what I did here, I just introduced a router. This is a CSR 1000V router, just connected here, and I created 2 loopback interfaces, 1.1.1/32 and 2.2.2/32. Okay, so from here we added static routes. I think I've already done that. That says, so here on this public interface, remember, so here is 192.168.1.30/24. I don't remember what we have here, but it should be something around the same subnet, 68 dot. I think I used 1.100/24. Okay, so there's a static route that tells these Juniper devices that to get to these two subnets, send it to this IP. Okay, same way for the entire subnet here is 10.0.0.0/16. Okay, so I also configure the static route here that says to get to this subnet, send it to 1.30. I mean, that's basic static routing. Okay, so what we're going to do is from these devices, right, we're going to configure IP monitoring. We're going to be tracking these IPs. Okay, and then we're going to say at any point these IPs are not reachable. So here what we'll do is we'll set threshold as what now? We set the threshold value as 200 and we'll tie weight of 100 to each of these IPs. Pretty simple, right? Then we give the global weight as 255. Okay, that's just what we're going to do. And then for us to test, because the last, this design is actually not, it's not really the best design, because here we're having one last mile connection, right? The connectivity to the internet is just one, so it really doesn't, it's not really a perfect fit for what we are trying to implement. But what we're just going to do is we're going to take the one link coming from the primary, which in this case is port 3, GE0/0/0/3. We're going to look at the corresponding port on the switch. We just shut it down, right? It means the one link is broken. So that should tell these routers that, oh, so he will not be able to ping these IPs. I said he, this router, right? So the primary will not be able to ping these IPs, and then we should see automatic failover to the secondary. Okay, I think that's as basic as possible for our testing, right? And then of course in the real world you probably will need to have, if it's a data center, definitely you're going to have two redundant connections, right? So that's what we need to do. Then the second thing is there are some caveats that are tied to this. Now the question is this: here the IP is 192.168.1.30, right? Remember, the IP is not tied to the physical interface, it's tied to, I think it's rect 0. Okay, and when you configure this IP, it's the same IP here, right? So 192.168.1.30, which is the same as the rect 0. Okay, so the question is, how does the secondary ping the gateway that you have here actually? Okay, because remember the IPs are the same. Now if you look at Juniper documentation, what they tell us here is that for this primary, remember this is primary, remember this is where you have your routing engine, okay, right? And you also have your PFE, right? PFE is something they also call the SPU. Okay, PFE is I think packet forwarding engine, so they work hand in hand with the routing engine. But here, because this is secondary, the routing engine is not active, so what you only have is the PFE. Okay, now the routing engine does the app resolution, okay, right? And I think PFE is responsible for sending the pings, the probes, right? So this is responsible for, right? The probes depends on the threshold you set. Now what happens within the primary is that it's going to take the direct MAC address. It's going to take the direct MAC address and the IP address of your interface as the source. Okay, so it's take this IP, take the MAC address on the direct interface and use it as the source to the pings. But on the secondary, you know that the IP is still the same and the MAC address maybe could be different, but the IP is the same. Now what is happening here is the PFE in this case will handle the both app, app request, resolving the app request. But in this case, it's not going to use the physical IP that is on the direct interface. It's going to need a secondary IP address. Okay, so it's going to take the secondary IP address and the child interface MAC address. Okay, MAC address to do its pinging. Okay, so that's how secondary is still able to ping this IP that you have here, whether it's 1.1 or whatever IPs you have here, using this information. So therefore means when we are configuring IP monitoring, then we'll need to specify a secondary address. Now the secondary address needs to be on the same subnet as the primary. So maybe here we can say secondary address is 192.168.1.31/24. Okay, yeah, so it's as basic as that. So that's what we are going to implement now. We're just going to do the testing, and then we'll see how it works. So something we'll do on the router, just for us to see that, oh, that the secondary is actually, we need to figure out a way to see that, oh, secondary is actually using what's it called, where is the yeah. So here I'm going to create an access list, okay, on this router. I wanted to use a Linux device, but I figured out it's easy using a router. So we create an access list, right? So that access list, we are going to be matching the two IPs. So we know the primary IP is what? 192.168.1.30. We know the secondary IP, which is used by the secondary node, will be 192.168.1.31. Okay, so we're just going to create an access list. We don't need to deny, but it's just like to see the hit count, right? We see if this is matched, and when this is matched, you're going to figure out that the secondary when the secondary is pinging, it's going to be sourcing from the secondary IP that is configured here. Okay, so that's what we need to do. Now, something else we can quickly clear out is this. Now, the question is this. So, let's do it this way. So now what happens? So we have node 0, which is our primary. You have node 1, which is a secondary. Let's just call this action. Okay, so let's say on node 0 it's reachable. On node 1 the IP is also reachable. What happens? There's no action, right? No action. Nothing is done, right? Primary continuous primary, secondary continuous secondary. Now what happens if node 0 the IP is reachable? The IP you are pinging is reachable, but here it's unreachable. What happens? Still no action, because primary is reachable, continuous as reachable, right? Now what happens if here it's unreachable, but here it is reachable? Then there will be failover, right? Yeah, there will be failover. What will happen if here is unreachable and here is also unreachable, right? There will still be no action. So you just need to have this in the back of your mind, that the only time you have failover is when you know, the primary is not able to reach the IP, the IP that we are tracking. Okay, yeah, I think we've covered some of the basic things that we need to. There are some few caveats as well, like they say that you can't track. So if I have a rect interface that has two sub interfaces, not sub interfaces, let's say two physical interface, right? Let's say it's a 1 gig link, right? Inside this rect 0, then they say IP monitoring is not supported, so you can't use this interface. That's one of the warnings that they tell you. Okay, and then they also said that XRS uses the lowest interface in the bundle for tracking the secondary nodes. So in our case, it doesn't really apply because we are not using two 1 gig link, right? We are just using one link within the direct interface. So there could be situations where you can do IP monitoring when you have that. Okay, we've said a lot. I think it's time to do the implementation. Okay, so I'm just going to bring up let's bring up the CLI. Let me make it a little bigger, smaller, I mean. And let's do our testing. Let's go back to the main topology, which is what you have here. And let's begin our testing. Okay, normal. The servers are pinging the internet. They've been pinging the internet all day. And this is my gateway that I told you about. Okay. So if I do show IP interface brief, which is the router, so we actually have this these two IPs here. Let's be sure. I want to be sure the static route is still there. I just added it when I was doing the testing. And so we have a static route that says, okay, so this is actually /24, so it doesn't really matter, okay, because we are not really pinging the servers. So we should be able to ping them though. So I can ping the servers behind the firewall. One is 10. I think the other one is 20. We don't really need to rush them. And then we can ping the gateways on the XRS firewall, which is 192.168.1.30. We should have been able to ping them. So 192.168. Yeah. So let's even be sure our IP is still there. Yeah. So it's .100. Let's just check from primary ping 192.168.1.100. Yeah, so reachability is actually there. Probably I'm not sure why the firewalls are not responding to the pings. Okay, so let's do our configuration. Okay, I think that's the first thing we need to do. So we just need to come and we can do our verification first. Show chassis cluster status. We already know this. So the 0 is currently primary for both redundancy group. Show chassis cluster interfaces. Yeah, so our monitoring is still there. Okay, our monitoring is still there and everything seems okay. And then you can say show chassis cluster information. Okay, so this gives you like the history of what has been going on between each redundancy group. So let's configure. So the first thing is to say so here we need to first of all define our global weight, which is what we talked about. So I'm just going to say set chassis cluster. In our case, it's going to be for redundancy group 1. So don't do, you can't configure IP monitoring for redundancy group 0, please. Okay. I think it's also there where they say you shouldn't do that, right? In most cases, you just leave redundancy group 0, which is the routing engine, to itself, right? You don't want to do IP monitoring. Imagine you are pinging Google DNS, let's say 8.8.8, and if it's not reachable, you are moving your routing engine from one device to the other. I mean, that will be very disruptive because the internet could still be working, but Google IP is not pingable for any reason. Okay, so you don't want to do that. So I'm just going to say for redundancy group 1, and then we can say our global, then we can say IP monitoring, right? Set the global weight. We're going to set it to 255. So you want to set it to 255 because remember, this global weight is not the global weight for the redundancy, it's for IP monitoring. Okay, so if you don't set the value as 255, and let's say we set it as 240, if you minus 240 from 255, which is the redundancy group value for group 1, then the value you still have 10, it's not 0, so you now have failover. So I'm going to set it to 255. We're also going to set the threshold to 200, and then we set threshold IP monitoring global threshold to, we set it as 200. Okay, and yeah, so once we have that, we can set the, if you're not sure, you can just do a question mark, you should get the other options. So we need to set it, we set the threshold, we set the weight. So retry count is going to be 5. So if we don't get, send 5 pings 5 times, try 5 times. So retry interval, then you can, they are not specifying the value here, but we can just say 1 seconds. Okay, so should pipe compare. Yeah, so we know commit check, I should take it. So we just hit commit. Good. So we can now configure our IP tracking. Set chassis cluster IP monitoring. Set chassis cluster. Let's say redundancy group 1 IP monitoring. Then we say, let me make this screen bigger. So here we say, let's do question mark. We can say family, right? So that's where we inet. Then we say 1.1.1.1. Yeah, I don't think we need to specify the subnet. No, so we just say give it a weight. We said the weight should be 100, right? Then the second one is 2.2.2. Now you also need to specify the interface that you need to use to reach that IP. So we say interface. We know it's our rect 0, right? Remember, our rect 0 is the one link. And then we can say our secondary address is going to be 192.168.1.31, right? Yeah. And so we do the same thing for 2.2.2. 2.2.2, no, not good. 2.2.2. And we still do the same thing, but we just change the IP here. So here should be 2.2.2, 2.2.2. So if I'm going to say show pipe compare, yeah. So it's very straightforward. So the family is IPv4 address family. So for 1.1, we're giving it a weight of 100. Here we're giving it a weight of 200. We're specifying the interface we want to use, right? We're using the rect interface. Remember, if you're using the rect interface, it can have more than one physical port in the rect interface. That's what Juniper is saying. I didn't actually test it. Maybe try to throw in more interface and see if it works. But I mean, that's what they say. Then this secondary IP address that we set has to be there. Okay. So the secondary, whoever is secondary at any instance is going to be using this IP as its source. Okay. Yeah, so we can say commit checks. And we say commit and quit. Okay, so I can come here and I say show chassis cluster redundancy group 1. Let's see. So status, let's do status first. Then I think the command is IP monitoring. IP monitoring. And then we can say status. Okay, so this is what it's telling us now. So that for redundancy group 1, node 0, for node 0, redundancy group 1, the IPs are reachable. So you see the weight we configured, they are there, right? So you see the threshold is 200, right? Current threshold is 200, right? Why the global threshold is 200 as well, because both IPs are reachable. So what we might do is we could just try to maybe create an access list to deny access to 1.1, and then we see this value is going to reduce to 100, right? So same thing for node 1, it's also able to reach those IPs. Okay, yeah, so everything is fine. So so if we do our show chassis cluster status, you see node 0 is still the primary. Remember, we say reachable, no action, right? So what we can do is we can try to deny the primary from being able to reach those IPs, and then we see what happens. An easy way to do that is, this is my switch. So if I do show LLDP neighbors, so we know that we are getting to, so this is the primary, and we are using all these ports. I really don't know what the port is on the switch, so it's better I do it from the firewall. So show LLDP neighbors. Yep. So we already know our one link is port 3, which is on the node. So this is our so, but why is this saying it's ret 1? Okay, I think we made some mistakes here then. So the interface should actually be rect1, not rect0. Okay, so the one link is actually rect1, so we need to quickly fix that. My bad. So I'm going to say show configuration pipe display sets. This is actually a mistake from my end, so we just quickly fix it. So I'm just going to copy this, put it in a notepad, right? Let me drag a notepad here, Control N. So to correct that, we just need to say, we put my alternate key and put here as, we don't really need all of that. We just need to say delete this. I think this should take everything out. Okay, so like I said, I need to quickly make the correction, and then we just put this there. So I need to come here, so and then say delete and copy. So just apply this commit. So that should take everything out, I think. So run show configuration, pipe display sets. Yeah, so it's taken out, so we just update it to, we just need to update it to rect1. So here should be rect1 instead of rect0. Rect1. Okay, so I can apply, commit and quit. So yeah, so we can see show LLDP neighbors again. So we know that rect1 is connected to port, is on port 10, right, on the primary, because this is our primary. Yeah, so on the switch end, this is the port, so that's what we need to shut down. So config T, then we say interface this. So let's just check our last status, show chassis cluster status. Okay, so we know that the 0 is still the primary, so we can go to the switch now and say shut down. Okay, it's down now. So if we do show IP status, right, so you see that no 0, the IPs are not reachable. Okay, so what happens? Threshold, current threshold value is -200, which is deducted from the global threshold, and bam, this is going to be deducted from the global threshold value, the tolerance value at the redundancy level. Okay, so what that means is you should have a switch over. Okay, yeah, so there's a switch over for redundancy group 1. Okay, so there's a switch over because the IPs we are trying to ping is not reachable. Yeah, so that's really the it's a very straightforward thing to implement. Okay, and something else we can do. Okay, so let's see how is the secondary reaching the pinging those gateways. Okay, so this is my router. I already created an access list here, but I think I took it off. Okay, so what we can just do is we can come to this access list. So show run pipe section access list. This is Cisco now. And we can just come here and see, we can say 10. So we're going to permit host 192.168.1.31, right, to any. Yeah, okay, so permit IP. Okay, so we can also say permits IP again, which is host 192.168.1.30 Okay, so show run pipe section access list. Yeah, so if we say show access list now, so you see there's a hit count on so there's a hit count only on the 1.30. Okay, so what is happening is when we shut that port down, right? So the redundancy, there was a failover, right? So let me see if I can describe it here. So primary is not able to reach 1.1.1, right? So there's a failover from the primary to the secondary. He becomes primary. When he becomes primary, he's going to be using his physical the IPs on the direct interface, right? Which is the .30, right? That's what he's going to be using, right? So whoever is primary uses the IP on the direct interface and the MAC address to source. Okay, remember here, this port will shut it down, so we will not be able to get anything from here. Now, let's move it back to the primary, and then let's see if we'll get hit count on both access lists. So what we'll do is, so I'll go back to the switch, delete this, come here, and then, yeah, so we're just going to the switch and say no shot. Okay, so we are restoring the connection. And the cluster there should be, of course there will be hold on timer, right? The hold on timer will still apply, but let's see. Yeah, you see the value is already back to 0, so it's going to go back to 255 now, and then there should be transition once the hold on timer has expired. But let's see, is it reachable now? So it still says unreachable, so we might need to give it time. Yeah, so it's reachable now, right? So the traffic should move back. Yeah, so the traffic has gone back. Now let's just check the gateway and see if those, so you see there's two matches. So secondary is using this as a source, right? While the primary continues to use 1.30, right? Yeah, so I believe it's very clear. Something else we could have tried here is, I don't know if it's going to work, is to say, I'm going to say do show run pipe section access list. Okay, so I want to deny one of the IPs, right? So I'm going to come here. I'm going to say 5. I'm going to say deny IP host. Let's say 192.168.1.30 to 1.1.1 to host. Let's just say host 1.1.1. Let's see how this is going to work. Okay, so it means 1.30 is not able to reach this IP. There won't be failover, but we should see some changes. So let's come here and say show chassis cluster status. Yeah, node 0 has gone to the secondary. It shouldn't really be that way, but let's see. Show chassis cluster IP monitoring. Show chassis cluster. Yes, IP monitoring status. Sorry. Yeah, so it's only one IP that is not reachable. It shouldn't trigger the global threshold, right? Because if you take minus 100 from the global threshold of 200, even the secondary is also saying, see what is happening here. And it says secondary app entry not found. So my expectation was that the secondary should still be able to reach it, right? From the access list we created. Let's look at the access list again. Show run pipe section access list. So we're only denying this IP from being able to reach 1.1.1. Every other service should still be reachable. Let's see what the access list can say. Show access list. Yeah, so it looks like it's denying both the primary and the secondary. Okay, I'm not really sure. I'll probably have to check after this video on why the behavior seems that way. But of course, we've been able to test what we need to test. Show chassis cluster status. Okay. So it looks like it's back. So it looks like it's back to the primary again. So what's really happening, I'm not sure. And okay. Well, it's still not, it shouldn't be, we're still not getting the right result, right? So I think it really comes down to how the two devices are sourcing the pings. Okay, it comes down to how both devices are sourcing their pings in this case. I'll probably have to check behind to see what is really going on. But of course, we've been able to test the failovers and we see everything is working fine in our case. Yeah, so thank you very much. I'm not sure there's still additional. So the only thing that is left is we can try to just test link aggregation. Okay, maybe on the LAN side. So what I'll do on the next video is I'm going to try to bring in 2 additional physical ports. Okay, so let's say we have another port here, and then we have another port here, and then we just add them to LACP. Okay, just to see, you know, how it works. Yeah, so we'll do that, and after that we start moving into other domains. Like, remember, this is the main topology. So once that is fixed, it means we are really done with everything related to clustering. So the first thing we'll do is we'll set up site-to-site VPN between these 2 devices. We'll also do it to the ASA. Okay, and then we can look at some variations where you have overlapping subnets, right? Then we also look at, oh, if this server is trying to ping this server, where the traffic has to go through, you know, there's helping in, as Cisco call it. We're also going to see if that implementation is possible for Juniper. And then of course later we start talking about remote access VPN. So there's still a lot to talk about. If you like this video, please subscribe, please like, share, and subscribe so that when new videos come out, you get a notification. Thank you, and see you in the next video. Bye.